All right, we're kind of identifying key features of functions today. I hope you find it friendly. Ask me any questions if you need more follow-up. Here's a new phrase right here, local minimum. Let's see, I am also going to add on this one, I think we should also find the local maximum just to talk. If I said find the maximum of this function right here. Yeah, and doesn't that arrow imply that it goes up forever? So the biggest number would be infinity, right? That's why we add this word right here, local. That means find the peaks and the valleys. Okay, so if it wants the local maximum or the local minimum, we're just looking for the peaks and the valleys. So right here, it says all local minimum values of G versus all values at which G has a local minimum. Now, Alex is kind of mean, and we'll flip those back and forth. One of them means the X, and one of them means the Y. And so you just have to pay attention and figure out which is which. So ignore the black that I wrote in for a second, but which one of these do you think is the X, and which one do you think is the Y? Excuse me.
I feel like B is X, A is Y.
She's absolutely right.
I know, what can I say?
She is absolutely right. All values at which G has a local minimum. So where is the minimum? We're looking for the X. What is its value? So value is the Y. Okay, what does it equal? So I'm going to start with this one. All values at which G has a minimum. We are looking here and here, right? Aren't those the low points in our function? Okay, so let's look for our X values. This one goes with -4. And then this one goes with 2. And I had a question last week, what are those little curly things? Those French braces are just, it means the set. These are our answers. I know. I know, they've got all these fancy names, huh? Okay, so if I'm going back here, all local minimum values of G. So I'm looking at the Y's now. This is at the same level, isn't it? And it equals what? -5. Where is my local maximum? I'm not going to write this down. I just want to talk about it. Where's the local maximum?
Isn't it like infinity because it's still going up?
Local means the valley or the peak. So if I'm looking for the maximum, I'm looking for that peak right there. So it's at -1. Its value is +1. Hard to see, isn't it? Okay. Now we're just going to talk about some features of functions here compared to the graph of y equals x. Is y equals x minus 2, is it steeper or less steep or the same steepness? Do you remember how to even figure that out? If we have y equals mx plus b and it's been a minute since we talked about it, what does the m refer to? Slope. Yeah, the slope. So if you look at both of these, what's in front of the x? If it's not written, what number do we assume it is? It's 1x, right? So if this one has an m of 1 and this one has an m of 1, their slope is it the same or is it different? It's the same. So if their slope is the same, aren't they equally steep?
Yeah.
What does that -2 do to the graph, though?
Makes it positive? Wait. -2 goes
I was trying to figure out where I'm going to write it. So if this is y equals x right here, what it does is it moves it down and just puts it down there through -2.
Oh.
So what if it was a y equals x plus 3? Where would it move it?
Yeah.
Yeah, it'd move it up. It'd have the same, well, if I could draw it the same, it'd have the same steepness, but it would be moved up 3. And we'll focus more on that later. But if we're talking about steepness, we're looking at what's in front of the x. The bigger the number, the steeper it is. Okay? So what about this one? We've got y equals x, and then we have y equals 5/3 x. So if I said the bigger the number, the steeper it is, here it is again, we can't see it, but is 1 bigger or is 5/3 bigger? 5/3 is bigger, so this line,
It's going straight up.
it's going to be steeper. Yeah, that's what you mean though. You mean it's steeper. Okay, now we're going to label this if it's increasing, decreasing, or constant. Increasing, decreasing, or constant. I'm going to zoom in here. We read, in fact, I'm going to put that right here. Read from left to right. Read from left to right. So if I start right here, look at this little piece right here. Is it decreasing, increasing, or is it constant? Decreasing.
And then it's constant, and then it's up increasing.
I don't have room to write all those, so I'm going to say that's constant. This one is increasing, and then it is constant.
This is like the easiest thing.
Is this a friendly game?
Yeah.
So far this was the hardest stuff right here. Okay, and the next one is pick a graph that describes or reflects the story problem. Chow rides down an escalator towards the ground.
B.
Not down an escalator. Is that down? Is that down?
No.
That would be a scary escalator ride. Yeah, right? So B. That is it.
Well, no.